Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
I'm fine, thank you. Hi, fellow Econauts. Hi, Simon. How's it going? What's the topic today?
Topic today is spin launch.
Hit the intro.
So, what is spin launch?
Well, spin launch is an alternative and innovative way to send payload into space by spinning it very, very fast and then releasing it when it has reached the orbital velocity. That's in a nutshell, I guess.
Basically, like a space gun.
Yeah, pretty much. It's sort of, the idea sending something by shooting it into space is not new. I mean, Jules Verne has written his book From Earth to Moon about this topic, sending pretty much a bullet to the moon. And a railgun sending some payload into orbit would sort of is conceptually the same thing. Spin launch has another spin to it because it's literally, as I just explained, it's a huge apparatus. It's as big as the Liberty statue in New York, and it can take up a payload up to 400 kilogram, accelerates it for 30 minutes, and then when it's fast enough, it gets released in the direction it has to be released and then can enter the orbit.
I think a very good question at this point is like to see the advantages and disadvantages of this concept.
Advantages is it's a little bit less expensive than sending something with Falcon 9 from SpaceX into orbit. I think difference is like 6 to 2 about, so it's a third of the price, and it doesn't use any rocket fuel. So obviously you don't have to store any rocket fuel and so on. Obviously, it also comes with disadvantages because, as I just mentioned, payload can only be as heavy as 400 kilogram, and it needs to be able to be accelerated for 30 minutes at 10,000 G.
That means that you cannot send humans into space and any kind of organic material, pretty much.
Yeah, pretty much. And also lots of technical devices need to be, designed in a way. Now you could argue the money you save in actually sending something into space might have to be spent in the design phase to actually, make your payload resistant to these high G forces, additionally to all the other harsh conditions you have to survive for things that are actually in space and out of our atmosphere.
One aspect that I like that we talked about before we started the show is the innovation of spin launch demonstrates very well the need of the space industry to actually send something into space. Maybe you can add something to that.
I think one, as you just mentioned it in a nutshell, spin launch demonstrates the desperation that the space industry has to find more access to inject payload into orbit. And for smaller payload, it might be a viable option. Depends obviously where you want to reach. You cannot reach anything further than in low Earth orbit or close to it with spin launch. So you couldn't send anything to the moon or to Mars with it. Or you would have to accelerate it even further. I'm not even sure if it's physically possible. Also, one thing I forgot to mention, obviously you accelerate in the spin launch in vacuum. Just a side note before anybody raises their finger, hey, you have to say this as well. But coming back to the initial question, yes, it shows the desperation that we need to inject payload into space and find more and more cost-efficient ways. And I think this is the key aspect here: cost-efficient ways to send payload into orbit. Especially low Earth orbit is currently very interesting, and until 2035 will continue to be the main focus for commercial entities. And then from 2035, there are strong indicators that the lunar economy will be more important.
I also think it shows or demonstrates very well the desperation for building more spaceports, if I'm honest with you, because right now we have a very limited amount on spaceports available that would allow us to reach orbit. It doesn't matter which kind of orbit we're talking about. Um, and it demonstrates, in my opinion, very well the need of sending something into space, which indicates also that we do not have enough platforms available to actually send something into space. Wouldn't you agree with that?
Slightly yes, slightly no, depending on what payload size we're talking about. For light launches, there's a number of launch facilities available, especially in the United States, but they're all very different in what they can launch and how they launch and how they can operate and how often they can launch. If we go towards heavy launch, then we are extremely limited in not only from where we can launch, because obviously we can't launch a heavy rocket from the poles, for example. Um, but then obviously there's other factors that are required for an ideal location to send heavy and super heavy payload into space. And especially if we want to send something to Mars, we cannot get away with a light launch. The Ariane 6, for example, which we talked about in another episode, is also sent from a close to the equator location, and that is also a rocket that is capable to go to Mars. So that would be something spin launch cannot service. But for smaller and for maybe even for more innovative companies that look for ways to send remote sensing equipment into low Earth orbit, a spin launch might be a viable option and might be more cost effective, depending on uh, the requirements the 10,000 G imposes on their payload.
All right. Well, then let's end it for today. That was a very nice and interesting episode. Thank you very much for your time. If you like this episode, please don't forget to leave a like and subscribe if you haven't already.
And don't forget to hit that notification bell. Also, we have already a number of episodes, and we would like to invite you to watch those as well. You can find them in the list of our site.
All right. I hope we'll see you next time. Have a good one. Bye bye.
Bye.